Hi everyone, today I am going to explain how to generate the pulses by using the DSP digital signal processor TMS320F28335 from this video. So for that, first of all we have to create the one separate folder for that. So here I am creating one folder like DSP, and in this folder I have several files. So but here in this folder I have to create one Simulink file. So that Simulink file I am name as a sign test. Okay, so that Simulink file I can open from here. So it will be looking like this. This is the Simulink file which I am opening from that folder. And so initially we have to do the same folder path. We have to copy here. This is the path we have to copy here and paste the same path in MATLAB command window. Thereby we can access all file in that folder from here. Okay, now from here I will open the required file to generate the pulses from the DSP. So this is the file I have to open from that particular folder. So you see here it consisting of one power guide and one constant, and this is the repeating sequence to produce the carrier signal, and it is a control signal or modulating signal, and this is the relational operator. So the output of the relational operator is given to the GPIO pin. You know GPIO pin it is abbreviated as the general purpose input output pin. This is used for access the pulses which is generated from the DSP. Okay, I will explain later so how it will be configured. So initially in terms of power give, so we have to change the options like the simulation type must be a discrete, and the sampling time I am using here 1 e power minus 5 means 10 microseconds. And at the same time some of the settings which should be changed in the total simulation file is go for the modeling, and here you can go for the model settings. So you must change the model settings like here it is two settings we have to change. One is solver setting, another one is hardware setting. So first go for the solver setting. Your solver setting must be, the solver selection must be fixed step, and I am choosing ODE. So ODE 3, you can choose anything according to your requirement, but it is better to choose ODE 3, and I am using fixed step. The same time I am using here, sample times I am using here 1 e power minus 5. And similarly if you go for the hardware the next setting is hardware implementation. So after connecting your DSP to your system, so you have to select your board. In this case I am using TI Dolphino F28335 board, means it is named as the TMS320F28335. so that is why I am selecting the family, that is TI Dolphino F28335 board. So I will show you that board later, so which I am using here. And if you select here, so the device vendor automatically come here like a Texas Instruments, and device type is C2000. These settings should be followed so before going to the simulation. So after completing these changes, we can go for the MATLAB. So simulation file. Here another important thing is we have to configure our GPIO. So we know that this particular board having 87 GPIO pins. Among the 87 GPIO pins, you can choose anything according to the pin configuration. So here, so I'm using according to the pin configuration. So just for your clarification, I will show you the pin configuration also for this particular input. So go for the connection details of this particular board. if you see this here, different types of pins are there here. J1 will indicate the EPWM pin, J2 will indicate the some EPEQ pins, and similarly here J8 will indicate some GPIO pins from GPIO 60 to GPIO 48. So it is named as 1, 2, 3. Pin number 1 indicates the GPIO 60. So this J8 section, I'm using this J8 section. In that I am choosing GPIO 60 pin. Means the pin number 1 is called as a GPIO 60. The same thing I am configured in this simulation. So just for that you can open this one. You will open this one. Just you can choose here GPIO 56 to GPIO 63. So among that you can tick on the GPIO 60. You can tick on the GPIO 60 and apply. Means so by this configuration, so your output pin will be selected as J8 and pin number 1. So okay na? So after configuring this one, first save your file. You click on the save button, and sample stop time you better to use infinite. So click on the run button. So after click on the run button, so it will run. So after some time you will stop and you will see the output of the your circuit by using the scope. So this is my simulated output of the circuit. So it is here I am using 50% duty ratio, okay, to generate the pulses. Okay, after this you can go for the hardware options. After getting the hardware, after going to the hardware option, so there is a build option. So you can click on the build option. So if you click on the build option, your board already here selected as a TIF Dolphino F28335. So this will be generating a built code, or it will be generating a Code Composer Studio interface, and that we will see like this. So here after click on the build option, so go for the view diagnostics. It will open, it will take some time. View diagnostics. So if you click on the view diagnostics, the dialog box will be open like this, and if you scroll down this dialog box, you can find this one, open this link, open project in Code Composer Studio. So listen, so before doing this experiment, you must install the Code Composer Studio and their supporting files also. So in the next video I will explain how to install the Code Composer Studio and how to provide the interface between the MATLAB and Code Composer Studio by using control suite and by using the what is that one, C2000ware. Okay, but in this video I am only explaining how to generate the pulses. Right, after generating this link, you just click on this link, open project in Code Composer Studio. Because I am already installed in the Code Composer Studio in my system, so it will open. So automatically the Code Composer Studio will be open. So just wait, it will take some time. Okay, so after click on this, now the Code Composer Studio window will be open like this. Now see, here the window is open now. So after open the window, so you can go to your file. This will indicate, if you click on here, your file will be appear like this. This is your file. My file is named as a sign test. So I will select this sign test and go for the build process by clicking on this option, this hammering option. So the file will be built like this. So by clicking on the hammer option, the file will be built in a Code Composer Studio like this, and it will provide some information here in console video. You can see the some information regarding to the build process. So it will take some time to finish the total build process. So I think it will take 1 or 2 minutes. Now here the build process will be running in the Code Composer Studio. Now here it will show build finished. So after finishing the build, so you go for the debug. So here you click on the debug. You see here this green colored icon will provide the debug option. So you click on the debug option. So after click on the debug option, so target configuration we have to configure the it is required to configure our target. So you click on the S, and so you just file name is as it is. You can give as it is. File name is like this location also same, because you already create one folder in the on the desktop. All base files or background files are saved in that folder only, and at the same time it is also appeared in the MATLAB command window, no problem. So after this you can click on the finish. So after finishing that, so we have to configure our target. So here, so for configuring our target, so we need to configure connection as well as board or device. Here the connection represents the JTAG configuration. So which type of JTAG you have to use. I will show you the total hardware also at the end of this video. So here I am using JTAG configuration, that is Texas Instrument XDS 100V2 USB debug probe. This is used for communicating between the my host PC to DSP. Okay, I am selecting that one, and the board type I already told you that board type is TMS320F 28335. This is my board type, TMS320F 28335. Now I am click on that board and click on save. After click on the save, so if you want to test the connection, you can test the connection. Otherwise directly you can go for the debug. So in this I am also test the connection. So here it will give the 0 failed is 0, everything is scanned correctly. Now my target is configured correct manner. So then after this you can go for again debug process by using this green colored button. Now you can debug. After clicking on the debug button, so it will debug and it will generate the code like this. So this is the code generation. So by using the MATLAB interface with respect to the Code Composer Studio. So after generating the code, here again two buttons are there. One is the resume button, another one is the terminate button. You can use a resume button to see the output from the DSP in digital storage oscilloscope. So just click on the resume button and your output will be shown looking like this. So the pulse will be generating like this. This is the pulse generated from the DSP TMS320F 28335. Okay, and this is the hardware setup for this DSP. So here this is the main board and this is the JTAG I am using here. So this JTAG number also given here, some JTAG number also here you can find the JTAG number, and on board also you can find the type of the board. And here I am using two pins. One is this is the positive pin and this is the ground pin. Here ground I am selecting as a 14 pin according to the connection diagram. I am selecting 14 pin as a ground pin or 15 pin as a ground pin because 3 ground pins are available. You can refer the connection details. And first pin I am using as a active pin or some VDC or some active pin, and this 15 pin I am using as a ground pin, and these two are connected to the DSO here. So this DSO will show the pulses which is generated from the TMS320F 28335. This pulse you can directly give it to the any hardware, or you can directly run any OpenLRT circuit as a hardware. Thank you.